Hello, good morning, friend. Now let us see the electron affinity, that is also known as electron gain enthalpy. Okay, either you say electron affinity or electron gain enthalpy, both are the same terms, student. Electron gain enthalpy means that is enthalpy change when one electron has been gained by the atom. Okay, so let us read out the statement, then we will be able to understand. It is defined as the amount of energy released when one extra electron is added to a neutral isolated gaseous atom. So this is, suppose this is the neutral isolated gaseous atom, when one electron you are adding to this, so that is anion is forming, student. Anion, gaseous anion is forming, plus energy is released. This energy released is known as electron gain enthalpy. That is also, it can be that is the negative sign is mentioned here, student, as this is the exothermic process, students. Okay, if more energy released in this process, the higher is electron affinity. Electron affinity is the reverse of ionization energy. Okay, the minus E1 is the term, the first electron affinity, as it one involve in addition of only one electron. Second electron affinity is an element is defined as the amount of energy required to remove one more electron to its mono negative anions. Okay, m minus, to convert into m2 minus, that become the endothermic process. So second electron gain enthalpy is always the endothermic process, because you need to give the energy, you need to give the energy to really to add the one more electron. While in the first electron gain enthalpy, the energy will released, but while in the case of second electron gain enthalpy, here you can read out again, second electron affinity of an element is defined an amount of energy required. Okay, amount of energy required to add one more electron. Okay, to add one more electron. So that is second electron gain enthalpy is endothermic process. Trends across the period and group. So firstly, period, as we move across the period from left to right, since the electron being added in the same subcell, nuclear attraction increases, the size decreases, hence the electron affinity increases. Okay, now in the group, you see down the group, electron get added in a new subcell, and the size of atom is increases, the nuclear attraction is decreases, electron affinity also decreases. Electron affinity values are expressed in kilojoule per mole. Okay, student. So that is in period increases, and while in the group it is decreases. For example, what are the factors which is affecting, sir? Factor affecting the electron affinity. First one is atomic size. So electron affinity is proportional to atomic size. So greater the atomic size, lesser will be the electron affinity, right? Effective nuclear charge. So what is the electron affinity is proportional to Z effective, positive charge upon negative charge. Stability of completely filled or half filled orbital. Electron affinity of elements having full filled or half filled configuration is very less or zero. So for these elements, electron gain enthalpy will be positive, right? Now the next point, when you are going to study, student, what are the next point? Okay, so next point is, no, here they have mentioned electron gain enthalpy ns1 and np1 is there. Okay, so electron gain enthalpy np2 np3. Now variation of electron affinity, variation of electron affinity in the second period. So second period, what is there? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, then it is starting from the third period. Magnesium, phosphorus, arsenic, sodium, aluminum. This is 0, less 0, 0. So that is, they are saying that is neon, beryllium and nitrogen, they are the endothermic, student. They are saying this is the endothermic. Why this is being endothermic, student? You can check out, that is they have the stable configuration, completely filled, full fill or half filled. So they are having the 0, then boron, lithium, carbon, oxygen, fluorine. Third period, argon and magnesium, they have the stable configuration, this is the ns2, completely filled. So they also have what, student? That is 0, or you can say endothermic. Now in the group, electron affinity of the third period element is greater than the electron affinity of second period element respectively. Respective group. Fluorine and chlorine, if you see, due to small size of fluorine, electron density around the nucleus increases. You know, the increase the incoming electron suffers more repulsion. In case of the chlorine, density decreases due to large size, decreases order. The electron affinity order is chlorine, fluorine, bromine and iodine. So fluorine is less. Why? Because of small size, addition of electron is difficult. Next point, if you see, student, that is what is the sulfur, oxygen, phosphorus and nitrogen. So sulfur is having the less electron and affinity because of small size. Sulfur, selenium, oxygen, so that's okay. Silicon, carbon, so silicon is having more affinity than the carbon. Note, ionization enthalpy of neutral atom, electron and equal to electron affinity of is unipositive ion. So ionization enthalpy of X equal to electron affinity of X plus. Assuming all the element, chlorine has the maximum electron affinity. The metal which has higher electron affinity is the gold. Higher electron affinity is gold. Hydrogen is minus 73, lithium minus 60, okay, sodium minus 53, so these groups are there, they have mentioned the electron affinity. Okay, now what they are saying, electron affinity of some main group element. So this is the first group element and a fourth A element, oxygen family. So and this is the you know other group, so they did not mention properly. Okay, so for the for this one, uh, you know six group, 141, 200, 195, 190, 174 they have mentioned here. Also you can check out. Among the halogen, the order of electron affinity value is chlorine, fluorine, bromine, iodine. Decreasing order of electron value of chalcogen, sulfur, selenium, tellurium and oxygen. From the thermodynamics, ionization energy and electron affinity. Ionization energy and electron affinity are defined as the absolute zero at any other temperature. Heat capacity for the reactant and the product have to be taken into account, right? Next point, if you see, student, this is the other terms they have. Enthalpy of reaction they have given कि m gas is converting into, for the ionization, for electron gain enthalpy, electron added, here released, here added. So delta H naught T equal to delta RS, no, they have CPDT. The value of Cp each species above the reaction is 5 by 2R. Cb is equal to 3 by 2R. So these are the thermodynamics, electron affinity is minus 5.2 RT. Okay. So this is all about the electron gain enthalpy, student. Thank you so much for watching, friends.